This problem, we're trying to find the square root of a complex number. A very interesting concept. And the way that the Lumen work addresses it, they use DeMoivre's theorem for this. There's actually another process you can do for, but we'll go with what they're doing, and they come up with a single root. There's really, if you're doing like an nth root, there's going to be n solution or to n answers to it. But we'll go with what they're doing to keep it simple. So we'll start off by saying z equals the negative 4 plus 2i, which means the magnitude of z is going to be the square root of negative 4 squared plus 2 squared, or the square root of 16 plus 4, which is the square root of 20. I'm going to leave it a square root of 20, especially for the calculations we're doing. I could make it 2 root 5. I started doing that. I'm like, nah, it just makes it messier trying to put it in the calculator. Now, our graph is negative 4, 2, so it's right over here. So when I look at, and I do that because tangent theta is going to be the y over the x, so 2 over negative 4, or negative 1/2. Now theta is going to return a negative value, so if I do tangent inverse of negative 1/2, it's really going to give me a value down here. And so I'm going to have to add pi to it to get to the value I want. So theta would be negative 0.4636. So if I add pi to that, I have 2.6779. So what we're looking at is that our z could be represented as the square root of 20 times cosine of 2.6779 plus I sine of 2.6779. So the simple way that your book here is showing how to do this z to the 1/2 would be taking that square root of 20, raising to the 1/2 power, and I realize square root of 20 is already the 1/2, so essentially the 1/4 power, 20 to the 1/4. Then cosine of 2.6779 divided by 2, because it's 1/2. It's like multiplying by 1/2. Plus I sine of 2.6779 divided by 2, so just that number part, not the whole sine part. And when you throw that in the calculator, you get a fun-filled answer of z to the 1/2 being 0.4859 plus 2.05817 I. Now, I am, disclaimer, going to tell you that there is another answer you could get, and I'm not going to do it because that's not where this book goes, but those of you in math land who are seeing me give one solution here, I realize there's a second one, but in order to be consistent with this book and not confuse my students, I'm just going to stop here. So there's probably enough, though. So I will talk to you all later.